Welcome everyone to another Eckerson Group webinar. Glad to have you with us. Today, our topic is blending data mesh and data fabric, crafting a balanced data strategy. We are glad to have you here on All Hallows Eve. Let's go to the next slide. Well, probably before the housekeeping, we've got our speaker today is Jay Piccionary, longtime Eckerson Group analyst and consultant. Been doing data analytics for over 25 years, been a data architect, data engineer, and data leader. And yours truly is going to be the moderator of this session. And we hope to make it an interactive session. Jay's going to present a few slides. He and I will talk after most slides, and then we'll bring you into the conversation. And if you want additional information about this or other topics, Eckerson Group has created these wonderful topic pages. And each of the topics has 18 or more different resources from our archives and our partners that you can read to drill down and get more information. So we just posted our topic page to data mesh and data fabric. So a lot of good stuff up there, both reports and articles and webinars and podcasts and events. So check it out. And now I'd like to turn this over to Jay, who's been studying data mesh, data fabric, probably more than anyone here at Eckerson Group. And I'm looking forward to hearing his thoughts about the topic. Go ahead, take it away, Jay.
All right, thanks, Wayne. So today we're going to talk about data mesh and data fabric. First, we'll take a step back and compare the two approaches at a high level. And then we'll talk about what we mean by blending data mesh and data fabric. And then how do you practically do this blending? We believe that data products are the common thread between these two approaches. So let's start. We'll start with a poll. So yeah, Julie, if you could put the poll up. Yeah, so we'd like to know where you are at right now. Are you using or plan to use data mesh or data fabric or some combination thereof, or neither? Or you're not sure, which is a little further down on the choices.
Okay, you don't see that up there.
It's there's a little scroll bar at the side of the poll where you can.
Oh yeah, there it is. Okay, I see it now. So I'm gonna vote.
Yeah.
Maybe I shouldn't, because we're like the cobbler's children here, you know.
Right.
I guess. All right, I'll vote.
Okay.
Oh, it's hard to see those numbers.
All right.
They're coming in though.
Yeah.
It's a race to the finish. Look at that. Wow.
Interesting.
I've never seen a poll have such even results.
Yeah, well, that's kind of going with all the polls this time of year.
That's true. The dead heat.
Yeah.
A dead heat between, with the data mesh is a little bit further out front, right?
Yeah.
Data fabric a little bit behind, but both people are implementing both. Well, I think that's going to reinforce the message you're going to present today.
Yeah.
That's pretty cool. All right.
Okay. So can we go back to the slides? Okay. So let's start with a little overview of data mesh and data fabric, and what I like to think of as these misconceptions where data mesh and data fabric are mutually exclusive. They're certainly very distinct approaches, but there has been a little bit of what happens often in our industry where, sort of a tribal behavior happens and you're in one camp or the other. And if you're with one, you're against the other, and you have to choose one over the other. And I think that's the premise of our presentation today is that's not really the case. While they are distinct approaches, they each offer ways to deal with modern data that apply to just about any organization. And neither of these approaches necessarily fit perfectly for any given organization. So how can you take parts of each and blend them together in a way that makes sense for your organization? So let's start first by
hold on one second, Jay.
Yeah.
If you go back to that slide, I love the graphic, by the way. And
whoops,
yeah,
wrong
well,
way. There we go.
there you go. Yeah. I've been in the industry for over 30 years, and for some reason, and I don't know if anyone can explain this out there in the audience, but architecture makes people very dogmatic.
Yeah.
And people get into these religious wars. Certainly, it's not as bad as the old Kimball Inman days, right? But you're starting to see a little bit of this dogmatism in data mesh versus data fabric versus lake house versus data warehouse.
Yeah.
I also see that there's a tendency for people to, throw out the baby with the bathwater, right? So, oh, a new approach comes along, therefore we're going to jump on that and abandon what we did beforehand, right? So the data warehouse has kind of been replaced by these more modern approaches, but I often see that some of the things that we learned in the data warehouse are still valid and appropriate today, but people forget. In fact, we have to remind people, hey, the star schema is still a valid approach to present data to users. So anyway, I just wanted to make that comment.
Yeah, it's true. I think you could take this, this little meme image here and replace the labels with a number of things. Like you said, Inman versus Kimball, Agile versus Waterfall, you name it. There are always these debates that go on in our industry that make it that are presented as one or the other. But inevitably, what happens is you end up taking what works, which is usually elements of both.
Or everything that's come before and after, which I would like to advocate for. But we got some questions and comments already coming in. Great. So one question from Risho: are data platforms like Databricks, Snowflake, and Microsoft Fabric a mesh or a fabric? You want to take that now, or do you want to postpone that?
Well, I think, the answer is going to be, it depends on how you implement them. There are certainly clues as to, what the vendors of those approaches think they are, right? Microsoft Data Fabric is a clue. Databricks is very much associated with the Lakehouse approach. So there's, in the end, I don't think they're necessarily either. It's how you implement them that matters. And let's take this opportunity to kind of compare and contrast the two approaches, because they, like I said earlier, they're distinctly different in their concept. The Fabric is really much more of a centralized approach, where you have a number of different capabilities within your data landscape that are offered to to all participants, sources and consumers and data creators, right? And it's really a technology-driven approach. It doesn't propose any particular organizational changes. And I think the core of it, which we'll talk about a little bit more later, is the extent to which it relies on abstraction to simplify a very complex underlying data landscape, to make it easier for people who want to consume that data, people and services and applications that want to consume that data, and not to have to worry about the details of where the data is or what format it's in, just to understand what it is and what it means and what you can use it for. So conversely, data mesh is a decentralized approach. It really promotes domain ownership of data, which is basically saying, like, different business units or operational units within an organization own their data, and they're responsible for creating, in the data mesh terms, data products which serve their organization and primarily, but their domain primarily, but also can be consumed by others outside of the domain if what they've created fits their purposes. So it depends on how your organization, what the culture of your organization is. If you're already a decentralized organization, then that fits well. If you're kind of more in a top-down controlled organization, and there can be good reasons for that, then giving ownership to the domains may be a more of an organizational change, which is why it's as opposed to being technology driven. It's really kind of organizationally driven.
Yeah.
And we'll talk about that in a moment.
So
yeah, go
I'm
ahead.
going to chime in here, Jay, for just a second. So yeah, I like this description. I've always thought of data fabric as a distributed data architecture, technology architecture, whereas the data mesh is a decentralized organizational architecture. And I think that reinforces what you were saying. And
Yeah.
I think we'll get into this, but I think the irony about the data mesh in reality is that if you're going to implement it properly, because it can just spin out of control and just spawn all these data silos, right? So to implement it properly, you're going to need a centralized data architecture, which may be the fabric. So I'm eager to hear what you're going to say on that.
Yeah.
So another comment just came in from Dan. Very often business needs translate to cross-domain requirements. How does the mesh respond to that? Yeah, well, yeah, that is a fundamental flaw of the data mesh. We'll get into that, Dan, I think, in a little bit. And another question just came in. Shouldn't the organizational data management maturity also play into these conversations? Absolutely, in my opinion. Jay,
Yes.
you want to comment on that?
Yeah, and in fact, we're going to talk about that in a little later, right? We're going to talk about what aspects of a company's culture and their data and their business sort of makes them a better fit for one approach or the other, or as you'll see, how to blend the two together with more or less elements of each, depending on what you're trying to achieve and where your organization is. But to kind of really drill in a little bit on what we mean about how data mesh is different, right? So if you have a centralized analytics data management approach, you have the way in which mesh is saying you should change is to shift left in a data flow, right? Where data in this metaphor, data flows from left to right. The source is at the left. The centralized management infrastructure is on the right, and their rallying cry is shift left. Move the data closer to the source, closer to the domains that are creating and using the data. And the advantages to doing that is that it gives that domain more control over their data. It takes them out of this centralized bottleneck, and if appropriately managed through what data mesh calls their federated computational governance, then you can avoid the data silos problem. But that's easier said than done. And we'll talk a little bit more about the trade-offs between these two in a moment.
So Jay, I gotta intercede here for a second. I wonder if any shift actually happens for two reasons. One, most companies already have compute and data storage and data processing happening out in the business units or departments, just through mergers and acquisitions or just the natural dynamics of how data evolves in organizations. If there's a bottleneck at the center, ambitious business leaders are going to go hire their own people and buy their own tools and start doing themselves. So I think every organization is mesh ready to some extent because they've got data silos. And I suspect just the degree of siloness is going to dictate whether the mesh is something that is going to help you or hurt you. I'm wondering what you think about whether there's ever a shift going on here. Does anyone ever dismantle their centralized architecture and do like the purest data mesh people say, which is get rid of IT, get rid of your data warehouse, get rid of your data lake, which I think is a recipe for disaster. But I'll let you respond.
Yeah. I think, well, first of all, I don't think that the data mesh proponents are really saying get rid of IT. What they're trying to do is eliminate the bottleneck of monolithic centralized approaches, right? So it's kind of derived from service-oriented architecture, right, which decomposes problems into small bites that can be combined together with a messaging service that can allow you to publish an output and subscribe to a service. that's the mentality behind it. And reading Zhamak Dehghani's writings on this, she's really coming at it from an architectural point of view and trying to do what, decomposing data in such a way similar to the way you decomposed application functionality into bite-sized pieces. I think, to your point, does the shift actually happen? I think it depends on what kind of an organization you are. If you're adopting this and you're not already, a large organization made up of a lot of software engineers, for example, because each of the domains would, if they're in this shift, each of these domains would take over, engineering and administering their own data products and the environments in which they live. Some organizations, particularly like cloud native organizations, are kind of built that way. For example, from my own experience, Amazon is very much built that way. So this wouldn't be a big change for them. In fact, you could consider them already doing it. But if you take a highly regulated organization, in financial services or healthcare, pharmaceuticals, that kind of thing, this may be a tougher road to travel, and to go to the pure, the purest way of implementing mesh is going to involve a significant organizational change, and some of which may not necessarily be even possible, because if you're regulated and you need to be able to assure compliance to regulations, domain A and domain B are both on the hook to do that, and you want to leave it to their own devices to figure out how to do that. That's the conundrum.
So Jay, I want to just go back to Zhamak, right? She's the kind of the inventor of the data mesh, and she came from a software engineering, object-oriented background, and it did strike me after reading all of her stuff that she's trying to reinvent data as a software engineer, right, and apply those object-oriented practices to data, which I'm not sure it's going to work in the purest sense of that methodology and approach. But anyway, we have a few comments here. Just going to address these before we get too far down. So Prakash is asking, won't this increase operating costs? And I think that's probably applied to data mesh. And probably on the surface, yes, but maybe not in reality, depending on how you deploy it. What do you think?
So it can, if you're going to let each domain replicate its own, create its own infrastructure, which is not really what data mesh is calling for, right? But if you're doing that, then yes. But the trade-off here is, and the whole principle here is that to provide the domains the agility to respond to constantly changing business environment. So are the costs, if you are driving up costs doing it this way, does the business advantage offset those costs? And I think that's the ROI, calculation you have to make.
Question from Melind. Shouldn't the organizational data management maturity also play into these conversations? Decisions about which architecture?
Definitely. And like I said, we'll go over some of the characteristics of an organization of which data maturity is an important one. So let me by contrast, let's kind of bring up the fabric approach, right? And I think one of the key aspects of fabric is the fact that its primary job is to provide an abstraction layer between the source data, which is it can be anywhere. It's very diverse in terms of its location, in terms of its format, in terms of the cadence in which transactions occur or operational events occur. So in order to consume that data, the abstraction aspect of fabric provides a way to hide that complexity from users and applications that want to consume the data. There are a number of different services that are part of the fabric, and they all need to be well integrated. But on top of it all is this layer that hides that complexity from the consumers of data, whether they're people or processes.
Now, Jay, you and I have gone around and around a few times on the word abstraction versus virtualization. Because in
Yes.
my mind's eye, and I'm maybe too old school here, is that this data fabric to me is just another name for data virtualization, which was EII. I mean, it had so many names going back 30 years. It's this old technology that's being reinvented. As things have gotten more distributed, we need a way to go out and get data where it resides without having to move it, right? Necessarily move it until performance comes an issue. So what is, I mean, is this just a glorified data virtualization tool? And why don't you like that word? You know?
Well, because virtualization is too narrow. So look, let me define abstraction in this context. It's a way of elevating some aspects of, in this case, data, and kind of making other aspects of it less noticeable or less relevant. So it's a way of creating a focus on what's important. So what's important about the data, from somebody who's consuming it for other purposes other than its original, operational purpose, where the source is they don't really care where, they don't want to have to worry about where it is. So that's a detail that abstraction makes less important for them to know. What format the data is in is also something that the abstraction layer makes less important. Now, the difference whether or not you persist an abstracted data object is the difference between virtualization and not, right? So let's take what you mentioned earlier, the star schema, right? That's a data model that is definitely an abstraction of the source data because it presents it in a much different format. But it's also persisted, so it's not, in most cases, right? There are some simpler star schema that can be virtualized, but in most cases it's persisted. And that's the difference between virtualization and abstraction. So abstraction encompasses virtualization, but it's not the only method of delivering the data. That's, for me, the difference.
Okay. I think it's tomato, because virtualization tools also physically, allow you still to physically materialize the data if you need to for performance reasons.
Yeah.
We got some other comments in here too. Let me go through these. Here's from Daniel. Actually, I love this statement, Daniel. I believe that you can have a centralized self-service platform, and every data product owner out in the domains can leverage it to manage data products. Yeah, I think that's right on. Paul Sargent says one answer is to assign the combined product to the domain which is the best fit. That's the answer to a question on cross-domain, which is a very tricky thing to do in data mesh, which I think we'll get to. Let's see. Ruan says it should also be said that the domain teams themselves should be willing participants. Yeah, that's very true. Yeah.
Yes.
And you're not going to get every domain team to want to do this, right? If they themselves are reluctant to take ownership of cross-domain assets, it might be better to continue to doing them centrally. Yeah, it's well said.
And that is also something that has come up within the data mesh world, is that there are categories of data like master data, for example. If one of your domains is one product line and the other domain is another product line, who owns the master set of all products?
Yeah, right. Customer or product.
Yeah.
Yeah.
Or customer, right? Another one. So there can still be aspects of data that are more centrally owned. But even if one of the things that data mesh is trying to address, what you alluded to earlier, Wayne, is specifically trying to make data approachable for kind of the standard version of a software engineer, right? So make it something that they recognize in terms of the patterns in which the patterns you use to deal with it. That was trying to get around the bottlenecks of not having enough data skill to get to make the data available to people. So making data look and feel more like application objects means that you can use a broader set of resources in terms of software engineers to do that work. That was kind of part of the principle of data mesh. But then, you have to have the software engineers as well, and
software or data engineers.
Well, no, I'm talking software engineers here. In the pure data mesh approach, that's what the recasting data in this software engineering architecture mindset was intended to do, is make it approachable to kind of garden variety software engineers as opposed to data engineers who know a lot.
Because they're more software engineers. And
right, exactly. I mean, for example, you can get a degree in software engineering. I don't know if an undergraduate degree in software engineering and then go on. There's still no data engineering degrees at the undergraduate level, and they're just starting to appear at the graduate.
So that's interesting.
Yeah.
I know we got to let you keep going here. We're getting a lot of great comments and questions.
Yeah.
Why don't you go another slide? Why don't you finish this section off, and we'll take the rest of the comments.
Yeah. So, some of the advantages and disadvantages we've kind of been talking about. So I think just take a moment to take this in and see if there are any comments on it. But we've covered most of this.
Okay. Well, then let's address some of these questions then. So here's a good one from Prakash. How does data mesh address the challenges of data silos, and how effective is it in large multi-domain organizations? Well, I'm going to take a first shot at this, if you don't mind, because data silos are a symptom of a dysfunction, right? Something's not working, or you had a merger and acquisition, right? Data silos mean your data doesn't reconcile across these silos, and data is not easily shared. And there's probably a bottleneck at the center, right? So how are you going to fix that dysfunction? Are you going to double down on the silos with a data mesh, which is a risky strategy from my perspective? I'm showing my bias. Because if you're already siloed, how do you intend to actually bring it all together if you double down on silos? Or do you centralize things, which, there's a risk there in creating a bottleneck? Or, in my humble opinion, the answer to everything is you federate. You do a little bit of both.
Yeah.
But Jay, I'm feeling your thunder a little bit. Go ahead.
Yeah, but that's kind of the answer to the question is, in theory, right? You have the 4 pillars of data mesh are domain-oriented ownership, data as a product, self-serve data platform, and federated computational governance, right? Those are the 4 pillars. The latter two, self-serve data platform and federated governance, gee, that sounds an awful lot like stuff you find in Fabric, right? So,
or data warehouse.
Yeah. So I think the answer is that first of all, there is a risk because what drives a company to want to shift left? It's the primary motivating need there is business agility, right?
Yeah.
And the road to data silos is paved in good business intentions, right? And
absolutely agree.
So I think this is really a matter of how you do that, because there's very definitely a need and demonstrated again and again over time as we look at sort of the older technologies like data warehousing and how in response to a modern data environment they can be a bottleneck and seem brittle and difficult to update, grow and evolve over time in a fast enough way. So how do you address that? Well, there's in the worst case scenario that you're describing, when you kind of chuck all that centralized control out the window and you let the domains do what they need to do, and that solves the agility problem, but then creates the management problem.
Yeah.
So it's, again, from my perspective, it's how do you blend the approaches, what each of these approaches is good at, and come up with combination of the two that suits your business. And that's the thing. The blending of these two approaches and taking the best of each is not going to be the same blend for one organization to another. Yeah. So let's move on and talk a little bit about, why would you blend? Because whatever your approach, architectural approach you're taking, there are certain things you need to do one way or another, and you need to provide, connectivity. You have to be able to transform data to suit a particular analytical purpose. You have to be able to monitor and mend problems within your operational infrastructure of your data landscape, and users need to be able to find and understand what data is available. All those, whether you're doing it as providing those capabilities in the context of one data product or as a centralized service, you've got these challenges that you need to confront.
So Jay, you'd be very happy to know that people who are listening here are doing exactly what you're saying, and they're sharing their stories here. So Vikram says can't get the company name on this yet, but he says we're using a combination of data mesh and fabric to deliver our data to end users. Is that something you're hearing other customers asking for the same? JP Morgan Chase has implemented data mesh for decentralization. I've written an article on LinkedIn about JP Morgan Chase being well positioned for data innovation through data analytics infrastructure. And Prab actually shared that link in the chat. So check that out. We should probably have Prab get on this call right now. I know we can elevate him and get his perspective. Maybe Julie can help us out on that. But Jay, why don't you keep going?
Sure. Okay, so here's, I think, where the rubber starts to meet the road, and I look at these two approaches as a spectrum of solutions, right? And you've got independent functions that are geared towards solving one category, a category of problems, right? Like business agility and how a particular domain sees its data. If they're the author of the data, then the terms and definitions and the way they model it is they're the ones who kind of define that, right? And you have local data operations where the cadence of how data is created and used for reporting and analytics differs from one place, from one business unit or function within a business to another. At the same time, you also have shared functions, which are kind of over on the fabric end of the spectrum, right? You have data quality standards that need to be, implemented universally, security and compliance. You need to be able to, for all the data that is out there, it has to be discoverable, right? And it also needs to be interoperable, and you have to have a place to put it. So how do you figure out for your company the appropriate blend of these independent functions versus shared functions, and leaning towards one side of the spectrum versus the other? That comes down to, what we've been talking about, which is, a lot of different aspects about your company, and dialing in the right combination it depends on, what kind of regulatory and compliance, requirements you have to meet. What's the cultural readiness for doing one versus the other? It may be that in an organization that is very much already distributed in terms of its decision making, and just in general, that the data mesh approach may fit culturally better because people are used to having that autonomy. Whereas in another kind of organization where it's more of a top-down control type of organization, making that shift is like I said earlier, a much bigger organizational change, and that makes the technical aspects of it more difficult. Data maturity is also, an aspect which folks have commented on, and in my experience, the road to data maturity, starting at a very low maturity, is generally starts through centralization in order to bring disciplines and a common approach to dealing with data. And then it can be federated after you've established a common reference point for what good data looks like, what it means to own data, for example. So all those are aspects of data maturity. Your need for business agility is going to drive you towards one end of that spectrum or the other, and then also just how complex things are is in your data environment, and the scale of it is another aspect of how you decide. Let's take a moment there and see if there's any other comments we want to acknowledge in the chat.
So Jay, we've done some technical wizardry behind the curtain here, and we are going to bring Prab Bala from JP Morgan Chase onto the stage. He's offered a link to an article that he wrote about doing exactly what you're recommending here. So Julie, can you bring Prab onto the stage and we can have him introduce himself and tell us quickly what he's done? See how this works here. We've never done this before. And we may never do it. We'll see. Oh, here he comes. Very nice.
Thank you.
Are you there?
Yeah. Can you see me?
We can hear
you.
You.
Hear you, but not see you.
Okay. I don't know why. Okay, there you go.
That's fine. It's fine if we can hear you. You can work on that. But maybe you could spend a couple seconds and just introduce yourself and your company.
Sure. My name is Prabhakaran Balasubramanian. I used to work for financial institutions in the past for 15 years almost. And then I'm an applied scientist. I finished my applied scientist on my way to PhD in data security and data analytics platform at George Washington University. And currently I'm with the Gilead Biopharma Research Company.
So you mentioned that do you work for JP Morgan Chase, or you just wrote an article about them?
No, only an article about them. That's what I have 15 plus years of experience in financial institutions and various brokerage firms, balance sheet management, and most parts of the Basel III framework architecture of financial institutions. So most of the areas of financial institutions I have worked. And the reason why I had to get out of a financial institution is that the lack of ability for normal organization other than JP Morgan to implement a data analytics infrastructure platform. So for data analytics platform, right now in the existing setup, as per my article, what I have written the general process operation of a financial institution from top down, from a system of records, whereby we have loans, we have deposits, and it flows all the ways from a loan deposit into QRM, the middle layer, and then to finally to the CEOs of the banks into balance sheet management. So in the complete entire financial architecture, so it's all the data architecture is all centralized database, and therefore decentralization. The reason why they have centralized database architecture is for regulatory framework.
Right. Jay
and in order for them to implement the disruptive AI technology, they need to somehow give the AI data analytics platform to the business owners. And this is where the data mesh architecture comes in play.
Interesting. Okay.
Yeah. So they are in between. They are right now centralized, But how am I supposed to decentralize the platform? So decentralize from halfway through, in which case half of the entire architecture, in the middle of the entire architecture, they have to decentralize. Then at that point of time, they can only give it to the IT infrastructure team to do the data analytics part. So not the business owners to do the data analytics part. For the business owners to do the data analytics part, the data mesh has to be implemented in the beginning itself. And then only it will be covered by the business owners. Otherwise, so the way JP Morgan currently does is they have the data mesh implemented separately from the existing centralized database architecture. So there are two lines, there are two paths. And that's the main reason why they have two separate paths, one for centralized regulatory framework, another one for disruptive AI technology. So because if a person or organization today doesn't have AI as a part of skill sets or as a part of the organization, they are on a threat to be thrown out of the market. Today, the world demands AI on everyone's plate. And therefore, the banks are now they have to insist the AI data analytics platform. So how they are going to do? They have centralized database for regulatory framework. That's fine. They have to build a separate channel for decentralized platform for the business owners to come up with the AI innovative architecture and so on. So the article.
Well, Bob, thank you so much. So what I'm hearing is that for regulatory reasons, like Jay mentioned, they have to maintain their centralized architecture, but to be agile and implement AI, they almost have to create this parallel universe, parallel data environment that's based on a data mesh, so the business units can actually do that kind of work without being, I guess, fettered by the regulatory approaches.
That's exactly right.
Yeah. So thank you so much, Prab. We're going to keep going with Jay's presentation. That was a great insight. Thank you for sharing and coming on stage.
Thank you.
Sight unseen. Okay. Thank you. Bye-bye. All right. We got a little color in there, Jay. So people are doing it. That was an interesting case study. And it's almost two bifurcated environments. But
and that kind of aligns with some research that we've done. Like, for example, American Express, huge financial institution, has traveled down this road in the way that Prab described, by creating a parallel universe, so to speak, for data to feed operational AI-driven processes, like a chatbot that helps a customer determine what kind of financial services from Amex they may need, for example. But I think where the ability to blend these two, for me, really comes down to this concept of data products. Now, data mesh introduced the idea, didn't invent the idea of data as a product, right? But certainly they're responsible for having shown such a bright light on it, and it's kind of become one of the central points of conversation around these, around data in a modern environment is. And so let's first talk about like what a data product is, right? So it's, as it says here, it's a data asset that has all the characteristics of something that can be bought and sold by people you don't know. So in other words, it's a data product is not necessarily a custom product, a custom data set that you make for a given use, where you know the users and you know how they're going to interact with it. It's something that is packaged, it's standardized, it's shoppable, it's deliverable, and it's returnable in a sense that you can figure out if you want to use it without committing to using it. necessarily. And data products these days are often found in a data marketplace. And I think, you know, the idea of a data product is what lets you can build a data product and implement it in a mesh environment. You can build a data product and implement it in a fabric environment or a hybridized version of the two. So if we take a look at where the data marketplace sits, it, you know, you can imagine that the services that a fabric provides that gives you the ability to connect to data sources, transform it, manage the operational processes, and observe and identify problems, and then creates the assets in a way that can be then packaged in the marketplace. So in the marketplace, what happens, the additional features that are added to an asset that make it more of a product are a standardized set of metadata that goes with the product that tells a consumer what the source of the data is, what the cadence of update is, what the appropriate business uses are for the data. Often they provide samples so that someone can see the data before they either gain access to it or request access to it. And the marketplace also allows you to search and browse, and different ways of doing this can be kind of standard catalog type browsing and searching, or there are now more products that are using natural language search to allow you to pose a question and then get a set of one or more data products back that may help you in answering that question. So I think, in terms of a practical approach, if you focus on treating data like a product, as something that has a life cycle and has value, and you create data products and make them available in a platform that enables consumers to understand what they're getting, just like you go and shop for a pair of pants and you know what color they're going to be, you know what size they are, and if you're in a physical store you can try them on and see if they fit, right? So that's the principle here that I think starts to bring these two approaches together in a practical and incrementally growable way.
So Jay,
yes,
I created this chart here. I recognize that. And we have data fabric kind of on the right-hand side. And I'm wondering if that's now, in hindsight, a mistake. Shouldn't it say data fabric or data mesh?
Well, actually the way I read this is that this data fabric box here sort of defines these four layers: connectivity, transform, orchestrate, observe, and assets, right? Yeah. And that AI and ML and metadata management and governance, fits over all of this, right?
So the mesh, as we said earlier, was more of an organizational architecture. This is a technical architecture, so maybe it is appropriate not to show it here. Okay.
Yeah, so that's we're getting towards the end here. I'll just do our wrap up.
Let me. Why don't we take some more questions here? We got a few.
Okay.
Then you can wrap up. Let's see here. A lot of good comments, people. This is great. Love to have you guys contribute. There was one tough question up here. Can active metadata intelligence support the abstraction of a data fabric? That's a term that some data catalog vendors have been using, right? Using metadata for governance, essentially, and proactively curating and stewarding data. Certainly a data catalog is going to be critical to any data architecture you implement. And in some ways, it's kind of the foundation for a data marketplace. In the diagram that Jay's showing here, that catalog and the metadata would be on the left-hand side there, data and metadata governance. Yeah. Can it support the abstraction of a data fabric?
I think
go ahead.
Yeah, I mean, I think the short answer to that is yes. In fact, it's within Data Fabric, it's assumed that automation is the only way you can really manage curating data these days, because it's changing so fast. So AI and ML driven automation to define, metadata attributes that that help manage the overall fabric integrations are critical. So that abstraction of like where is the data? There are processes that can generate connections. For example, you give it a source, it can read the source data through AI. If it's not structured data, it can try to discern, by looking at the data values, what type of data is in each position, et cetera. So I think it's, part of the Fabric assumption is that it relies very heavily on two things: metadata and AI and ML automation to make it.
Yeah, I think it's a semantic issue as well. So if by active metadata you mean the metadata in a data catalog, that's more static. But if you mean by active metadata, the metadata in a semantic layer that's designed to support query processing, then yes, it would.
Yeah.
Right? We would agree with that, right, Jay?
Yeah. Well, I mean, like active metadata would be part of the challenge is you have a data source, and the structure of that source, even if it's unstructured, the implied structure of it can change over time. Well, how do you know that's happening? In a data catalog, somebody else has to figure that out and then update the catalog. In this approach, the idea is to have a process that recognizes that and does something. It can be a warning to an administrator, or it can be automatically make a change, to say, for example, a catalog entry, that kind of thing.
Okay, last question here from Randy. It's a good one. So based on this discussion, does anyone actually implement only a data fabric or a data mesh? Do you have to do them together, I think is the question, or can you do them separately?
Yeah, I mean, there are certainly companies out there that are implementing what they would consider to be a pure approach, one way or the other. I noticed somebody made a comment about Roche implementing data mesh.
Yeah, we've written two articles on Roche.
Yeah. So I think, and we've talked to Paul Rankin, who's the guy who led that effort there. And I would say that, he talks about them implementing data mesh, but what they actually did is a bit of a combination.
Yeah.
He talks about the idea that he wanted to give the ability to the domains to create their own data, but they're a pharmaceutical company, so they're very highly regulated, and therefore their version of the mesh is what he described as sort of agile configuration. So there's a common service layer, and then there is a playbook that allows a domain to either use their own resources or bring on staff augmentation, and that they've got a simple playbook for how you get to data, and then what it needs to look like to be a data product, and where it needs to live to be a data product. So yeah, there are a lot of examples, I think, of companies that are intending to do both in a pure sense, but my argument would be that ultimately no matter how you label it, they're doing these things that are on the picture here today. And you can call it fabric, you can call it mesh, you can call it something in between, but you've got to do all this stuff.
Yeah. All right. We got 2 minutes here. Wow. There's one more good question. Oh, it keeps coming in and in. Can you provide a practical example of a single data product and illustrate what happens if users request additional features like cross-domain features? We had a client that built a data product. I will tell you, most people are still confused what a data product is until you are trying to build something for consumption by your customers or suppliers, which is what this client did. They were building a customer dashboard, right? And as a result, they were smart enough to realize, oh, we better have a product manager run this, because this is something that we care about and something we're going to continually enhance over time. And that So the question from Dan is, what happens if there are additional cross-domain features? Well, I can't remember the specifics of the dashboard. I'm sure they had cross-domain features, and I don't think they did not have a data mesh or data fabric. So this was all just modeled right in the background for that. So it's not a great example, Dan, but that's why you have product management. In fact, that's probably the most salient characteristic of a data product, is that you have a product manager who's designed to go gather requirements, ensure it gets developed, enhance it continually based on feedback. Anyway, Jay, why don't you wrap up here, since we hit the top of the hour, if you can do it in like 15 seconds, and then we'll give everybody a chance to go their own way.
Yeah, I think just to kind of, summarize what we've talked about, if we haven't learned it yet, it's going to be a tough road in the future, because, a modern data strategy has to be adaptable. Things are going to change, and the cadence of change is even faster than it used to be.
And architecture, right?
Yeah. And you have to find a balance that's appropriate to your organization, that between domain-specific needs, those independent functions, versus centralized controls or those shared functions. And every organization has some version of that, but from organization to organization, that's going to be different. So there's not like a one-size-fits-all approach to this. And as we were just talking about it, for me, I think the data products is kind of where you can figure out a practical way of defining this balance for your organization, and right down to, do you have to develop data products within a domain? No, you can have a centralized data team building data products, but treating data as a product with those capabilities that we talked about of making it so that someone who you didn't build it for can understand what it is and whether or not it meets their purposes is a key asset. And then the marketplace is where consumers go to find what they need. And if you have the appropriate metadata and controls over what gets published in the marketplace, then you've got, that ability to self-serve data goes way up.
Well, Jay, thank you so much for all your insights, and thank you to our wonderful audience with all your comments and questions. I think this is a very informative webinar. I certainly learned something, so I hope you did too. And until next time, signing off from Eckerson Group. Have a great rest of your day and a great Halloween.
All right. Take care. Bye.
Bye.